Welcome back. Problem 12-35. This problem is taken from chapter number 12, that is Deflection of Beams and Shaft, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the beam is subjected to the load shown. Determine the equation of elastic curve. EI is constant. So you can see the beam and the loading over here. There is a movement at this end and at this end, and point A and B there is a pin support, and there is a uniformly distributed load of 3 kips per feet over a length of 8 feet. So you have to find the equation of elastic curve. So we will to find equation of elastic curve. So let's start with the solution. So first step is that if you remove this pin support at A, so you will be having a reaction force. Let this reaction force is RA, and if you remove this pin support at point B, so you will be having a reaction force. Let this is RB. So we have RA and RB, so we will find them by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0, and taking the counterclockwise moment as positive. So about this point A, one moment is this 5 kips, that is counterclockwise, so it will be positive. So I will write it 5. The second movement is due to this force RB, and that is about point A is perpendicular distance is 8 feet, and this is producing counterclockwise, so it will be also positive. So I will write minus plus RB into 8. The third movement is this 5 kips into feet, that is clockwise, so minus 5. And the last movement that is produced due to this distributed load. So when this distributed load is converted into point load, so this will be equal to 3 into the length, which is 8 feet. So this is 24 kips force that is applied in the mid of, and this perpendicular distance will be equal to 4 feet about point A. So this is 4 feet. So this is also producing clockwise movement, so it will be negative. So I will write minus 24 into 4, and that their sum must be equal to 0. So this 5 will cancel with this. So we have 8 RB is equal to 24 multiplied by 4. So RB is equal to 24 multiplied by 4 divided by 8. So we will get 12 kips. So RB is equal to 12 kips. Now we will find RA. So for RA we will use another equation of equilibrium, that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA is upward and RB is upward. So RB is 12 kips plus RA minus this 24 kips. Their sum must be equal to 0. So from here you will get RA will be also equal to 12 kips. Okay. Now we have RA and RB. So we will move to find the equation of elastic curve that can be obtained by using equation EI into d square V over dx square is equal to moment. So we will find this moment by using Macaulay's method or Macaulay's function. So you can see here that you have moment, you have point loads, you have uniformly distributed load. So there is a table given in chapter number 12, that deflection of beam and shaft, and that table is 12-12. So here you can see for different type of loadings you have the equation of moment. So we will get the moment equation as a sum of all these functions. So first we will find the moment equation. So for that, if you draw this beam over here, let me draw it. So you can see at this end we have moment that is 5 kips into feet. At let this is your point A, so where there is a load of RA that is acting RA, and RA is 12. Let this point is your point number B, so where you have RB and uniformly distributed load between A and B. Let this is the uniformly distributed load. Okay, so this is acting downward. So now you can see that for movement we have this function, for concentrated load we have this function, and for uniformly distributed load we have this function. And this uniformly distributed load is 3 kips per feet. So what we will do is that if you look at case number 3, so uniformly distributed load starts from here till the end. But here you can see this distributed load start from here but not till end. So what we will do is that we will bring it till the end and we will subtract it in this portion, and this load will be upward in order to cancel the effect. So what we have done, we have added this in downward direction, and in order to cancel its effect, the same distributed load is also added but in opposite direction, so that these two cancel the effect. Now we will apply the equation of moment. So you can see from the table this moment will be equal to first load is the moment. So we will go to moment equation is this one. So here moment m naught is 5. So 5 into Macaulay bracket x minus a. Since you can see here this load, this is for the load of a and this is the a distance. Since in this case the moment is at this point, clear, so a is equal to 0, so x minus 0 power 0. Now we'll move toward this point load. Also you will have to be very careful that while you can see that the movement is in clockwise, here the movement is counterclockwise, so it will be negative. So for clockwise the movement equation will be plus this one, and for counterclockwise we will put negative. Now for P load, so you can see for point load this P is upward and that is acting at a distance of A from this end, clear. So this is RA. What we will with the equation, this load is upward, P is upward, so plus, because the moment equation is this one. So we will replace P with RA. So RA is 12 into x minus A. Now here you can see A act at a distance of 4 feet. So x minus 4 power 1. Okay. Now another thing is that you have this distributed load. You can see that is starting from this point till end, and this is the case. But here the load is upward, so moment equation is this one. So I will write, since this is downward, so it will be negative. So minus W naught is 3, so 3 by 2 into x minus A. And again you can see A will be 4 because W start from this point. So I will write x minus 4 power 2. Okay. The other thing is that we have this point load RB. So RB is upward, so plus RB is again 12, and we will go to the point load moment equation. So P into x minus, now distance of this point from this region is 12. So A is equal to 12 for RB. So x minus 12 power 1. And we have the last thing is this uniformly distributed load which we have acted downward. So it will be plus W naught is 3. So 3 over 2. This is the equation, 3 over 2 into x minus 12, because for this load, this distance, this is the A, and that is equal to 12 feet. So this is your moment equation. Clear? And at the end we have movement of 5 skips, that will be skip. Okay. So once we have the moment equation will be like this: minus 5 into x minus 0 power 0 plus 12 into x minus 4 minus 3 divided by 2 into x minus 4 whole square plus 12 into x minus 12 power 1 minus 3 over 2 into x minus 12 whole square. So this is the main equation. If you have learned this, so next the problem solution is very easy. So now you will put this equation, this A equation, and this is, let's say, number 1. So put equation A in equation number 1. So what we will get is that EI into d square v over dx square will be equal to moment, and moment will be equal to minus 5. X minus 0 is x power 0, so x power 0 is 1, so minus 5 plus 12 into x minus 4 minus 3 over 2 into x minus 4 whole square plus 12 into x minus 12 whole power 1 plus 3 over 2, this is plus 3 over 2 into x minus 12 square. Now integrate it once, integrate it, so we will get EI into dv over dx will be equal to minus 5x plus 12 into x minus 4 whole square divided by 2 minus 3 over 2 into x minus 4 power cube divided by 3 plus 12 into x minus 12 power 2 divided by 2 plus 3 over 2 into x minus 12 power 3 divided by 3. So simplify it, we will get minus 5x plus 6 into x minus 4 whole square minus 1 over 2 into x minus 4 whole cube plus 6 into x minus 12 whole square plus 1 over 2 into x minus 12 whole cube. Okay, so while taking the integration of equation number this equation, so there will be a constant of integration as well, that will be C1. So I will write C1. So EI into dv over dx. Let this is your equation number 2. This equation will define you or give you the slope. Again integrate equation number 2. So we will get EI, I will go direct, EI into V is equal to minus 5x square over 2 plus x minus 4 whole cube divided by 3. So 6 divided by 3 is 2 minus x minus 4 power 4 divided by 4, which is 1 over 8 plus x minus 12 whole cube divided by 3. So 6 divided by 3 is 2 plus x minus 12 whole power 4 divided by 4. So 1 over 2 multiplied by 4 is 1 over 8 plus C1x plus C2. And this is equal equation number 3. Now C1 and C2 are unknown constant of integration. and they will be defined by boundary condition. So we'll write boundary conditions. What are the boundary conditions? So first boundary condition is that at x is equal to 4 feet, we have deflection is equal to 0. So let me show you over here. So you can see at here x is equal to 4 feet. So we have deflection is equal to 0 because there is a support. Okay. So put in equation number 3 because equation number 3 is for deflection. So when you put in this equation, so we will get EI deflection is 0 is equal to minus 5 into x is 0. So this term will be equal to 0. So 0 plus this term will be equal to minus 4. So anything inside Macaulay bracket that is minus will be 0. Similarly, this term will be 0. This term will be 0. This term will be 0. And this term will be 0. So we will only left with C1, C2. And so from here you will get C2 is equal to 0. Okay. I think I made a mistake. We have to put x is equal to 4 feet. So make a correction that this will be not 0. So 5 minus 5 into x is 4. So 16 divided by 2 plus this term is 0 because 4 minus 4 is 0 minus 1 over 8. This term will be also 0 because x minus 4 minus 4 is 0 plus this term will be 4 minus 12 which is minus 8. So minus 8 Macaulay bracket, anything inside the Macaulay bracket is negative, will be considered as 0. So 0 again this term will be also 0 plus C1 into x which is 4C1 plus C2. So we will get 0 EI into 0 is 0. So this will be minus 40 plus 4C1 plus C2. So we will get 4C1 plus C2 is equal to 40. Let this is your equation number 4. Now we will use another boundary condition, and this boundary condition is at x is equal to 12 feet, we have deflection is equal to 0. So we will put in equation 3. Let me show you here. Here you can see at x is equal to 12 feet, we have deflection is equal to 0 because there is a support. Clear? So we will put it in equation number 3. So equation number 3 is this one. So we will write EI into 0 is equal to minus 5 into 12 square divided by 2 plus 2 into 12 minus 4. 12 minus 4 whole cube minus 1 over 8 into 12 minus 4 whole power 4 plus 2 into 12 minus 12 will be 0 plus 1 over 8 into 12 minus 12 whole 4 plus C1x. Cx is 12. So 12C1 plus C2. So this will be equal to 0 and we will get minus 360 plus 1024 from this term minus 512 plus 0 plus 0 plus 12 C1 plus C2. So from here you will get 12 C1 plus C2 will be equal to minus 152. This is your equation number 5. Now equation 4 and 5 are two simultaneous equation. So what we will do is that you can get from equation number 5, 12 C1 is equal to minus 152 plus C2 minus C2, and C1 is equal to minus 152 over 12 minus C2 over 12. So this is the value of C1. So if you put this value of C1 in equation number 4, so you will get C1 is equal to minus 24. So once you get C1 is minus 24, so you can again put it in equation number 4 R5. So you will get C2 will be equal to 136. Now you have C1 and C2. So we have been asked to find the equation of elastic curve. So this is the equation, this equation number 3. So I will copy equation number 3 and we will move toward the next page. Let me copy it. Okay, so we'll remove these upper terms. So we get C1 is equal to, C1 was minus 24 and C2 was 136. So put C1 and C2 in equation number 3. So you will get EI into V is equal to minus 5x square over 2 plus 2 into x minus 4 power 3 minus 1 over 8 into x minus 4 power 4 plus 2 into x minus 12 whole power 3 plus 1 over 8 into x minus 12 power 4 plus C1 is minus 24 into x plus C2 is 136. And if you divide EI on both sides, so you will get deflection. Our equation of deflections come out to be 1 over E into I into minus 5 over 2 is 2.5 minus 2.5 x square plus 2 into x minus 4 power 3 minus 1 over 8 into x minus 4 power 4 plus 2 into x minus 12 whole cube plus 1 over 8 into x minus 12 power 4 minus 24 x plus 136. And this is the answer, our required equation of elastic curve that will give you deflection at any instant of time or any length. So if you want to find deflection at any length of x, so just put the value of x, so you will get the deflection at that point. And that was all about this problem 12-35. I hope you have enjoyed this video and you have learned from it. I have tried my best to describe it in a simple or smartest way, and I hope you have enjoyed this video. If you have any question, you can ask me in comment section. Thank you for watching.